Hey everybody, welcome to your chemistry homework. Tonight we're learning about percent yield. You're going to find out what it is and what does it tell you after we do the calculation. So here we go. Percent yield is going to tell us the percentage of product we actually get as compared to the maximum amount that we could get. So what this means, if we go back to our food examples from Tuesday, if we go back to our food examples, let's say we have enough supplies to make 20 burgers. So theoretically, we could make 20 burgers because that's how much stuff we have. But as we're cooking the burgers, one of the burgers drops on the ground and the dog eats it. So really, we only make 19. We can only serve 19. We can only serve 19 burgers. So theoretically, we had enough stuff to make 20 burgers, but really we could only make 19 because we dropped one on the ground. We didn't make all that we could. So our percent yield on that, we actually made 19 burgers. We were supposed to make 20 burgers. We multiply by 100 to make it a percent, and we get on our calculator 19 divided by 20 times 100 equals 95%. We have a 95% yield. Now, in chemistry, that would be really, really good. But in real life, that's kind of bad to lose a burger. Hopefully, there weren't 20 people wanting to eat those 20 burgers. But whatever. Just an example. So, our equation for percent yield is right here. It's the actual yield divided by the theoretical yield multiplied by 100 to make it a percent. Definition of the actual yield. The actual yield is the actual amount of actual product you actually get in an actual experiment. An actual yield will have to be either measured in an experiment, or given in the problem. So the actual yield will be an actual amount of real life stuff. The theoretical yield is the calculated amount you try to get. So we can calculate this using stoichiometry, or sometimes it's given in the problem, but usually you have to calculate it. In real life, percent yield in chemistry especially will always be less than 100% for a variety of reasons. Those reasons include impurities in the chemicals. So chemicals aren't 100% pure. There's might be a little bit of water added to it. The chemical could be old and decomposed a little bit. But there's different impurities in chemicals that will keep you from getting 100% yield. Also, your lab techniques not being perfect, that keeps you from getting 100% yield. And reaction conditions. Reaction conditions include temperature. There's a perfect temperature that chemical reactions take place at, and each reaction's perfect temperature may not be room temperature, and we're definitely doing our experiments at room temperature, so temperature is one of those reaction conditions that would affect your percent yield. Humidity. If there's extra water in the air, then that could affect your percent yield. We've also even talked about the air conditioner being on or off in class and blowing on the scale, and that could affect your percent yield. If your measurements are wiggling around on the scale a little bit, then that could mean your measurements are a little bit off, and that would affect your percent yield. All right, so here's our first example. We have 64.8 grams of potassium chlorate. It decomposes, and 23.8 grams of oxygen is measured as a product. What's the percent yield? So notice in this problem that what is given our starting material, and what is asked for, the oxygen, two totally different chemicals. So this is our actual yield, and it's in oxygen, not in potassium chlorate. The subscripts on the chemical formulas didn't come out when it converted into this app, but that's what's going on with those numbers. So our starting chemical is different than our actual chemical. This means we need to do stoichiometry, and this is a stoichiometry problem kind of in disguise. It's only when they give you the same chemical in both numbers that you don't have to do stoichiometry. We definitely are doing a mass-to-mass problem in here because we're going to need to calculate our theoretical yield. So all of our stoichiometry problems start with a balanced chemical equation. Here it's given to you. This should be our arrow. And we have 2 moles of potassium chlorate breaking down into 2 moles of potassium chloride plus 3 moles of oxygen, which is diatomic gas. When we calculate our theoretical yield, we get to do a mass-to-mass problem. Pause the video now and try out your theoretical yield problem on your paper. Pause now. All right, so you should have done the problem already, and now you're coming back, and here we go. So 64.8 grams of KClO3 are going to be converted into moles in the first step, and those moles, oh, hold on one second, I need my calculator. Okay, got it. So, 64.8 grams of potassium chlorate. We're going to have grams of potassium chlorate on the bottom, always 1 mole when we're converting from grams to moles, and KClO3 on the top. Then we'll convert from KClO3, our starting material, to oxygen, our product, using our mole ratio and numbers from the balanced chemical equation. So that's 2 moles of potassium chlorate for 3 moles of oxygen. Now we want to compare grams to grams because they gave us grams in the actual yield up here. So we'll need to go all the way to grams, and 1 mole of oxygen, so our units cross cancel, has 32.00 grams in it. All right. Calculating my mass of potassium chlorate, I look on my periodic table and I find potassium's mass is 39.10 plus chlorine's mass at 35.45 plus 3 oxygens gives me total mass of 122.55. All right. So 64.8 divided by 122.55 times 3 divided by 2 times 32 gives me 3 sig figs, and those 3 sig figs are 25.4. So what makes these percent yield problems hard is not the 3-step calculation. It's now you're expected to know what these numbers mean. So what this number means is this 25.4 grams is the maximum amount of product that I could possibly make. And that product is oxygen gas. So 25.4 grams is the absolute most amount of oxygen that I could ever make from 64.8 grams of potassium chlorate. So that is my theoretical yield. I just calculated it. It's 25.4 grams. Now I go to my percent yield formula, which is actual divided by theoretical times 100. The actual yield is the actual amount of actual product actually given in the actual problem, which is 23.8 grams of oxygen. My theoretical yield is the maximum amount of product I could possibly make. and that is 25.4 grams. Multiply by 100 to make it a percent, and 23.8 divided by 25.4 is times 100 is 93.7%. 93.7%. So 93.7% product in that experiment, that's pretty good. Usually as a chemist, if you get over 90%, you're doing pretty awesome. If you're in the 80s, you're doing all right. And below 80% yield is kind of bad. So here's our first example. Second example, try it out on your paper. Right now, go. And here's what you should have. So C3H8 is a combustion reaction. So C3H8 is going to be our reactant. We're going to add it to oxygen and form two products, which would be carbon dioxide and water. Now we go to balance this equation, and we get 3 carbons on each side, 8 hydrogens on each side. 3 times 2 is 6, plus 4 is 10. That means 5 oxygens right here. Great. Now, they give us C3H8 to start with, and then we're measuring water. That means we're calculating our theoretical yield. They didn't give it to us. This is going to be our actual yield. And we use our starting materials to calculate our theoretical yield. So 44.1 grams of C3H8. We're going to water because that's what we're interested in. First step, grams C3H8. Only thing we can ever turn grams into is mole, and that will be 1. Then we use our mole ratio from our balanced chemical equation to turn 1 mole C3H8 into 4 moles of water. Last, 1 mole of water is going to turn into grams of water, and 18.02 comes from the periodic table. C3H8 mass, 3 times 12.01 plus 8.08 is going to give me 44.11. And 44.1 divided by 44.11 times 4 times 18.02 gives me 3 sig figs, 72.1. 72.1 grams of water. And that's the maximum amount of water that I can possibly produce. So here's my theoretical yield. They give me my actual yield in the actual problem. And so I can plug it in. My actual yield goes on top at 69.26 grams. My theoretical yield is 72.1 grams. And 69.26 divided by 72.1, times 100. Is 96.1%. 96.1%. All right, last little detail. It's important to note that that mathematically speaking, you can have a percent yield of over 100%, but you did something really wrong in that experiment if you ever do get something over 100%. That's it for notes tonight, and I'll see you in class tomorrow. Bye.